welcome to the Backyard Professor Math videos. We're going to continue on working with linear equations, equations that have, or formulas that have linear equation type looks and feels. And within the next couple of videos, we're going to start graphing linear equations, and we'll begin to see the real power of the mathematics of linear equations. We have 30 equals 6 times 6x plus 9. So we're told 30 is the answer to this equation once we figure out x. We have a 6 we're going to distribute into each term in the parenthesis. So this becomes 6 times 6x is 36x plus 6 times 9 is 54. And we're told 30 equals this. We want the x alone, so we have to subtract this number over here. So this is going to be 30 subtract 54 equals 36x, right? 30 subtract 54 is what? Negative 24 equals 36x. We're going to divide by 36 because we want to isolate the x. We divide here, so we divide there. Now we can see, I'm going to bring this number over to here, equals negative 24 over negative 36. It's a negative divided by a negative, so it's an even number of negatives. So this is going to end up being a positive answer. So let's just drop the negative signs to 24/36. You know these are even, they're both even, so they can be reduced. The question is, what number best used will reduce these? 6 is a factor of both 24 and 36, isn't it? If we take a 6 out of 24, we're left with 4. And if we take a 6 out of 36, we're left with a 6. But we see that's not enough, so we still have to reduce this by 2. 2 will go into 4 twice. 2 will go into 6 3 times. So we can see that 6 wasn't necessarily the best number to take out. We could have taken out 12. But I want you to see this, though. If you don't take out the largest factor out of each, you just keep reducing until you can't reduce. It's not wrong, it just gives you an extra step that you have to keep reducing to get to your answer. And 2/3 is your answer on that. Let's do some more. What if we have 3 times t minus 2, and we're told that this expression equals 9 times t plus 2. So here's an interesting situation where we have a variable on both sides of the equal sign, here and here. We have a number that's going to be distributed into those parentheses, a number that's going to be distributed to those terms in those parentheses. So let's do that first. We know we're going to use the distribution law because there's a number outside of the parentheses. So we distribute that in. This is going to be 3t, 3 times t, and 3 times negative 2 is negative 6. Notice this gets rid of the parenthesis because we've distributed it in. We no longer need the parenthesis. And then this is going to be 9t plus 9 times 2 is 18. So now we have this expression 3t minus 6 equals 9t plus 18. We want the t on the same side. So let's subtract 9t here. If we subtract 9t, we end up, I'm going to come over here, with negative 6t, right? 3 minus 9 is negative 6, and then we bring our t into it also. That eliminates the 9t here. Now we want to add 6 to both sides of this part of the equation. That'll cancel those two 6's, and it will add a 6 here. So negative 6t equals 24. 18 plus 6 is 24. How to get t all by itself? Divide by -6. On both sides, -6 into 24 goes in -4 times. And there's your answer, is -4. By just step by step using the laws that we know how to use, we can solve the equations. The answers almost just fall out as you solve these kind of equations, don't they? That is one of the most miraculous things about mathematics that I've discovered for myself. Let's do another one similar to that. That way we'll get good and used to this. We will love having practiced this when we get to graphing linear equations, as well as solving all kinds of word problems, because there's many word problems that work themselves into these kind of math equations. Being comfortable and familiar with these kind of math equations is excellent practice to solving real problems that we confront ourselves. Again, we have a number. We know we're going to distribute in the parenthesis. This side equals this side, and we're going to do the same thing. We're going to distribute this number in the parenthesis. Our goal is to isolate the variable. We always solve by isolating the variable, which is x. We see x on both sides of the equal sign. That doesn't bother us. We'll get them on one side or the other. So 2 times 5x is 10x. 2 times -3 is -6. Equals 3 times 3x is 9x. Times 3 times -1 is -3. Now we subtract x from here. We want to subtract 9x from here. That will cancel it. What we do to this side, we do to this side. So 10x minus 9x minus 6 equals -3. We want to add the 6. Since it's been subtracted, we add 6 to both sides. It will cancel here, so that 10x minus 9x is simply x. See, it already solves itself. X is equal to -3 plus 6, which is 3. 6 is the larger number. It's the positive number. The difference between 6 and -3 is 3. Therefore, we know it's going to be positive 3. X equals 3. Not too tough, is it? It's really not. The more we do these, the more comfortable we get with them. Y minus 2/5, here come the fractions, equals -2/5 plus y. Now we want to solve for y. We want to solve for the variable. Someone has come along and subtracted 2/5. We want to add 2/5. So y equals -2/5 plus 2/5 plus y. Right? Y equals -2/5 plus 2/5. -2 plus 2 is 0, so that's going to be 0. Y equals 0 plus y. This says y equals y. And that is a true statement. But the thing about this particular equation is, this is telling us that every number is a solution. It's an infinite number of solutions because y equals y. Kind of interesting to know that, huh? Okay, we're given 8m times 2 minus 6 minus 3 times 3 plus 3 equals 2m times 2 minus 8. So we have an expression minus an expression that's going to equal an expression. How do we do this? We know already how to do this, don't we? The operation says we have a number outside the terms of parenthesis, so we're going to distribute those numbers in first. 8m times 2 is 16m, minus 8m minus 6 is minus 48m, minus 3 times 3 is 9, 3 times 3 is 9. Now see what we did here. By distributing each term into that, we could, in this instance, since these are like terms, we could simply add those. So this would be like this, if we were to add these, would be 6, and negative 3 times 6 is negative 18, which is exactly that term. Negative 9 and negative 9, that's a plus negative, is negative 18. See how that works? That's kind of cool how that works. And then this equals 2m times 2 is 4m. 2m minus 8 is minus 16m. So we've got a great big long hairy expression here. So we can continue just systematically, step by step, solving this great big bad looking equation that's really not that tough. You collect the like terms. 16m minus 48m. We're going to subtract those. That's going to be 2. That's going to be negative 32m minus 18 equals, what's 4m minus 16m is minus 12m, equals negative 12m. Now we have m still on both sides of the equal sign with a negative 18. We want to put the m's on the same side, so let's bring the negative 32m over to here. We're going to add the 32m to get it to this side. If we add 32m here, it cancels it. And that's what we want to do. We want to pull it over to here. So that now we have negative 18 equals whatever these two equal. 32 and 12 is negative 18 equals 44. Whoops, nope, not 44, sorry. That's a negative 12 and 32, so it's like subtracting 12. Boy, you got to do your math right, huh? 20m. And now you're going to divide by 20m. By 20, sorry. You got to divide by 20 to isolate m. So you have a negative 18/20. You take out 2, and that's going to be negative 9/10. That's what m equals. It's a matter of simply, systematically applying whatever properties that we know of in order to simplify the expression, to gather our like terms, to coordinate the positive and negative numbers, put all of the variables onto one side of the equation, and solve the equation. It's truly, this is the essence of what it means to do math. And this is how we solve equations. Now, kind of a cool application here. We have a formula, m equals 1/5 t. And this formula is a linear equation. Now, what's interesting is, this is the formula that they use in weather. You know how you see lightning off on the distance and it strikes the horizon, it strikes down on the ground, and then you count, let's see, 1, 2, 3, 4, and then you hear the thunder. Well, this is the mathematical equation to figure out how far away the lightning is. This is the miles or distance, and this is the time. So how does this work? M equals 1/5 t. If you see lightning strike and you count 1, 2, 3, 4, 5, you count up to 5 seconds, this becomes m equals 1/5 times 5. the t. Now, you've seen expressions like this. Now you see a direct relation to something that really happens in the world. This is simply 5 over 1. Then you multiply across. 5 over 5 equals 1. What that tells you is, if you see lightning strike and it takes you 5 seconds to hear the thunder, the lightning was 1 mile away. Isn't that cool? So if you count for 10 seconds, if you hear it for 10 seconds, m equals 1/5 times 10. You put a 1 over the 10 just to keep it simple. You're going to be multiplying. It's 10 over 5. So 5 goes into 10 2 times. So with 5 seconds, you know it's 1 mile away. With 10 seconds, you know it's 2 miles away. And you can actually build up a chart that tells you, in relation to time, the distance of lightning away from you, based on hearing the thunder, because of this equation right here. Isn't that fun? That's kind of a real cool real world application to some fun physics stuff. And all kinds of physics have all kind of formulas. We're learning how to do the equations and formulas and getting used to the formulas. But I'll tell you what, when we begin doing physics, we're going to be very grateful we've had this kind of practice. If we have a formula of B equals 1/3 Q, now this is very similar. It's a different physics issue, but this is very similar to that M equals 1/5 T now, isn't it? It looks very similar. You see, formulas are not that difficult to understand because we've been learning the linear equations. We know how to deal with fractions next to variables. Isn't that cool? What if we were asked to solve this? Well, it sounds like the robins are out. They've got babies around. What if we're asked to solve this for Q? What do? How do we isolate Q? Here. We want B. It's been multiplied, so we're going to multiply it by the reciprocal. So B is going to equal 1/3 times 3 over 1 Q. And what that's going to do is going to make this 1Q. But what we multiply by here, which is basically 3, we're going to multiply by here. So that this equation, solving for Q, equals 3B equals Q. Isn't that interesting how that works? What if we do the distance formula? Distance equals rate times time. This is the exact linear equation types that we've been working with numbers. Now we just have the variables. What if you wanted to solve this for R? How do you solve nothing but a formula? The same way in algebra for R, we can see that someone's come along and multiplied T to R. We want to divide by T to get rid of the T on this side, right? That will cancel those out, leaving R by itself. But what we do to this, we have to do to that. So D over T equals R. And that makes sense because the distance divided by the time really does give you the rate. That's how that works. That's a great physics math equation. What if we're told that 9y equals 5x and we have to solve for y? How do you solve this for y? What that's saying is, when it says solve for y, you're given an equation or an expression, and they say solve for a variable, they're saying isolate that variable. So how do you isolate y? 9 has been multiplied to it. You divide by 9. You divide by 9. 5x over 9 equals y. That's all there is to it. You just simply do a little bit of division or else multiplication. Depending on what form of the formula you're working with, You undo what has been done to the variable. If we have AP equals BQ, and we're asked to solve for the letter P. You see, you don't even need numbers. You know exactly what to do. You say, okay, we have to solve for P. A times P, so we know someone multiplied A to it. We divide A, and we divide A here. BQ over A equals P. And that's how we isolate the variable. And then if there's numbers given to us, we plug and chug those numbers into the formula, and it works it out beautifully. Let's do another direct linear equation form. Y equals mx plus b. This is a classic linear equation form that we will begin to get very well familiar with. Let's say we're asked to solve for x at this point. How do we isolate x? B has been added to it, m has been multiplied to it. Well, we've done stuff like that. Just because it's in an equation with nothing but variables does not mean all of a sudden it's more difficult. We've been doing equations like this deliberately so that linear equations become easy. We subtract b for one thing. So this becomes y minus b equals mx, right? We want to isolate the x. M's been multiplied to it, so we have to divide by m on both sides. So y minus b divided by m equals x. And that's how you solve that kind of an equation. It's really not that difficult. It's the exact same thing if we have y equals mx plus b and we're told to solve for m. How do we solve for m? The same principle. We have b added, so we want to subtract b. We're going to isolate m. So y minus b equals mx. We want to isolate m, so we're going to divide this time by x. And that isolates m. When you divide by x, it cancels x, and there's your equation. Y minus b over x equals m. Y minus b over m equals x. It makes perfect, logical, consistent sense. This equation here, this y equals mx plus b, we will work with that extensively. We're going to memorize that plus a couple other formulas in linear equations. I guarantee we'll work with that hundreds of times. That's one of the most important linear equation formulas there is. Let's say circumference equals 2 pi r. Now this is the equation for a circle. We have this side of the equation, the circumference. We have a 2, a pi, and an r for the radius. Pi is simply 3.14. We're asked to solve this for r, which by now is child's play to us because we say we know this and this and this are all multiplied together. So to separate r, we divide by 2 pi. What we do to this side, we do to this side, and there's your answer. C over 2 pi equals r. That's how we've isolated the r. And then when you plug in the numbers, whatever numbers for whatever circle it is you're asked to solve, you simply plug in the numbers, and that gives you your answer for the radius of a circle. If we're asked 2 pi r, if we're asked to solve for pi, 2 times pi times r, we have to divide by 2r. So circumference is 2r. Pi, in this case, is going to equal circumference divided by 2r. And that will give us pi. You can see how you can manipulate this. It doesn't matter which variable you're asked to isolate. because we know how to do that, we can now begin working real well with physics formulas. Suppose you're asked to isolate 2, then you're going to divide pi and r. All of these have been multiplied. What you do to this side, you do to this side. So circumference divided by pi r is going to give you the number 2. Isn't that fascinating how that works? It's great to know how to physically manipulate the numbers in the equations so that we can begin solving problems. This is the essence of what linear equations do. So the next video we're going to do is I want to begin graphing linear equations and showing you how that expands our ability to understand the math. It's really great how that works. So happy calculating, man. Have a great life. Have a great day. It's a beautiful day today here where I'm at. Hope it's nice for you guys. And I'll see you in the next video.